This is the Algebra 1B exam review for Unit 5. As always, don't forget that you will be given a formula sheet. So you have all of these formulas to reference throughout the exam. And these are the formulas that you do not need to memorize. Question 71. Which graph below represents the function f of x equals the absolute value of x plus 3? Well, the thing we know about the absolute value graph is that its parent function of, let's say, f of x equals the absolute value of x is going to look like a V with the vertex at the origin. What we can see from this graph, or this function right here, is that we are horizontally translating it. Because the plus 3 is inside the function, it's a horizontal translation. So our absolute value function in general would be a times the absolute value of x minus h plus k. So this is our our horizontal translation, and it's always the opposite. Our vertex is going to be hk, and so our vertex, when we have plus 3, is going to be -3, 0. We have no vertical translation because k is 0, and because it's inside, it's the opposite. So our graph is going to be A, where the vertex is at -3, 0. For question 72, Jill takes a Sunday drive in her car. She drives at an average speed of 50 miles per hour for 3 hours. She takes a dinner break for 2 hours. After dinner, she travels at an average speed of 25 miles per hour for the next 4 hours. Let t represent the number of hours since she started. Let d of t represent the total distance that she has traveled after t hours. So we need to find the domain of t and then sketch a graph of d of t on the coordinate axis below. So first of all, she's driving for a total of 3 hours at first, and then she takes a 2-hour dinner break, and then she drives for another 4 hours. This gives us a total of 9 hours, meaning she's driving from 0 hours to 9 hours, and that is our domain. We're going to include both 0 and 9. And so our domain is going to be 0 is less than or equal to t, which is less than or equal to 9. You can also write it in the notation 0, 9 with brackets because we're including 0 and 9. Next, we need to sketch the graph. However, the first thing we need to figure out is how far she's traveling, because d of t is the distance. So for part 1, she's driving an average speed of 50 miles per hour for a total of 3 hours. 50 times 3 is 150. My hours cancel out, so I'm left with 150 miles. So she starts at 0, and at 0 time, she traveled 0 miles per hour. She's traveled a distance of 0. She's traveling 50 miles an hour for 3 hours. Or you can say that she's traveled 150 miles at the end. Either you can find the total distance, or you can also look at the slope, because speed is going to be the slope. So up 50 over 1, up 50 over 1, up 50 over 1, for a total of 3 hours. So we know that those are the points. We're going to connect those, and that's our first part. For part 2, she's taking a dinner break. So she's traveling 0 miles per hour times 2 hours. This means that she's traveling 0 miles for 2 hours. That means the slope is going to be 0 for a total of 2 hours. Finally, with the third part, she's traveling 25 miles per hour for a total of 4 hours. 25 times 4 is 100. So she travels for 100 miles. So from 150 miles, for another 4 hours, she's traveling another 100 miles, meaning she's going to 250. So at 9 hours, she's traveled 250 miles. We can also see this with our slope. Our slope is 25. So up 25 over 1, up 25 over 1, up 25 over 1, up 25 over 1 for a total of 4 hours. So we can see those are our points. We can connect them, and there's our graph of d of t. Next part is we need to write a piecewise function for d of t. So I like to break this up into the 3 parts and find the equation of each part. We already know the slope because we're given that with the speed. So for part 1, the slope is 50. For part 2, the slope is 0. And for part 3, the slope is 25. We're going to use the point slope form. So point slope form is y minus y1 equals m times x minus x1. But since we're writing this as a piecewise function, we need to add y1 on both sides so that we have it solve for y. Y equals m times x minus x1 plus y1. So for the first equation, the first part, we need a point and a slope. Let's pick our starting point of 0, 0. So I'm going to plug that in. Y equals m, which is 50, x minus the x value of my point, which is 0, plus the y value of my point, which is 0. So y is going to equal 50, x minus 0 is x, so 50x plus 0, or just 50x. We can also use y equals mx plus b, where we know our slope and we know our y-intercept. Either way, you're going to get this answer. For equation 2, we have y equals a slope of 0. We can pick a point like 3, 150. I always recommend you pick endpoints. So 0 times x minus 3 plus 150. Well, anything times 0 is 0, so 0 plus 150. Our equation is going to be y equals 150. For part 3, we need a point, so we can pick 5, 150, we could pick 9, 250, it doesn't matter. So I'll pick 5, 150. Y equals m, our slope in this case is 25, times x minus 5 plus 150. Now, I believe it's acceptable to keep your answer like this, but I like to simplify my answers. So I'm going to do the distributive property and write 25x, and 25 times negative 5 is negative 125, plus 150. So y is going to equal 25x, and then negative 125 plus 150 is positive 25. So my piecewise function, the first part of it, is going to be my first equation, which is 50x, my second equation, which is 150, and my third equation, which is 25x plus 25. I highly recommend you do this all in pieces, but whatever your preference is fine. So now I need to find my intervals. Well, this first part is from 0 to 3. So I'm going to write if 0 is less than or equal to t, which is less than or equal to 3. So this is a matter of preference. I'm going to say she's driving all the way up to 3 hours, and that's when she stops. So if that's true, my next one has got to be 3 is less than t, because I can't have it include 3 in both of them. Then I won't know which function to use. So in this case, she's going from 3 to 5. So I'm going to say 3 is less than t is less than 5. You could also say less than or equal to 5, as long as you're aware of that with the third equation. So because I said less than 5, my last equation is going to be 5 is less than or equal to t, and my interval is going to be from 5 to 9, so less than or equal to t, which is less than or equal to 9. And that is my piecewise function. So finally, part D says, what was Jill's average speed on the interval 0 is less than or equal to t, which is less than or equal to 9? Show how you determined your answer. Well, if you remember, D equals RT. She traveled a total distance, as you can see from here, of 250 miles in the span of 9 hours. So she traveled 250 miles equals rate times a time of 9 hours. If I'm going to solve for a rate, I'm going to divide by 9 hours on both sides. And I'm going to see that my rate is 250 divided by 9, which is approximately 27.778 miles per hour. So her average speed was about, let's say 27.8 miles per hour. Question 73. Bob uses sugar to make candy. Beginning at noon, t equals 0, he uses sugar at the rate of 100 pounds per hour. At 3 p.m., t equals 3, he starts using sugar at the rate of 50 pounds per hour. He stops making candy at 7 p.m., t equals 7. Let t represent the number of hours since noon. Let S of t represent the total amount of sugar that Bob has used after t hours. So part A says between noon and 7 p.m., what is the total amount of sugar that Bob uses? Well, from noon, t equals 0, to time, t equals 3, he's using sugar at the rate of 100 pounds per hour. So from t equals 0 to t equals 3, he's 100 pounds per hour times 3 hours. 100 times 3 is 300, so he's using 300 pounds. Then from t equals 3 to t equals 7, which is a total of 4 hours, he's using 50 pounds per hour for a total of 4 hours. And 50 times 4 is 200 pounds. So between noon and 7 p.m., he is using 300 pounds plus 200 pounds, which gives us a total of 500 pounds of sugar. So part B says on the coordinate graph below, make a continuous graph showing the total amount of sugar S of t that Bob uses as a function of t. Well, at 0, he starts at 0 pounds. After 3 hours, he's used a total of 300 pounds. We also can see this as the slope of 100 pounds. So 100 over 1, 100, up 100 over 1, up 100 over 1. So we can see that those points give us this graph. For the second part, from t equals 3 to t equals 7, he uses 200 pounds of sugar. So if he starts at 300, 300 plus 200 is 500, so he's up here. But we also can use our slope of 50 and see up 50 over 1, up 50 over 1, up 50 over 1, up 50 over 1. So it's going to give us these points, which gives us this part of the graph. And that is our continuous graph showing the total amount of sugar, S of t, that Bob uses as a function of t. For the last part, we're going to complete the piecewise function for the total amount of sugar that Bob uses. So we need to do it for two parts, and they've already set the intervals for us. So for part 1, we need to find the slope. This is part 1, this is part 2. So for the first part, our slope is 100. For the second part, our slope is 50. We also need a point, so we're going to use 0, 0 for this one, and we can use 7, 500 for this, for the second part. So for the first part, remember y equals mx minus x1 plus y1. Well, y is going to equal my slope of 100 times x minus 0 plus 0. This simplifies to 100x. Now, we use d of t and t, so I'm going to rewrite this as 100t. For the second part, we have y equals m times x minus x1 plus y1. So y equals m, which is 50, times x minus 7 plus 500. Now, this is an acceptable answer to leave here, as well as using the point 300. However, as I mentioned last time, I like to simplify it. So 50 times x is 50x. 50 times negative 7 is negative 350 plus 500. So y is going to equal 50x, and negative 350 plus 500 is 150. Again, I'm going to write it in terms of t because that's the proper term. This is going to be 500, sorry, not 500. 50t plus 150. And that is our piecewise function. Question 74. Which statement is true about the function f of x equals the square root of x? So if we graph our function, it's going to look something like this. We know that actually instead of using y, I'm going to write f of x. If x is 0, the square root of 0 is 0. If x is 1, the square root of 1 is 1. If x is 4, the square root is 2. And if x is 9, the square root of is 3. So this kind of gives us an impression of what the graph looks like, as well as some values. So statement A, both the domain and range is all real numbers. Well, we can visually see that no negative numbers work for the value of x, and there's no way we can get a negative f of x. So this is absolutely not true. Statement B says both the domain and range is all real numbers greater than or equal to 0. Well, we can see with our domain, we start at 0 and it works, and it's all real numbers greater than or equal to 0. But we can also see that with our range. Our range starts at 0 as well, and it goes up, albeit slowly, but it still goes up. So this is a true statement. However, we should look at C and D just to make sure that we're correct. So C says the domain is all real numbers. The range is all real numbers greater than or equal to 0. Well, we know that this statement right here is false, so it can't be C. Statement D says the domain is all real numbers greater than or equal to 0. That's true. And the range is all real numbers. Well, we know this statement is false, so we know D doesn't work and B is our answer. 75 says look at the graphs of f of x equals the floor function of x and g of x equals the ceiling function of x below. Now granted, remember those are the nicknames, but I think that nicknames are so much more useful than the actual names of the function because floor, round down, ceiling, round up. So which of the following statements is true? For every value of x, floor function of x is greater than the ceiling function of x. The best way to answer these questions is to pick an example. So, for instance, let's look at when x is 1/2. So, when we have the floor function of 1/2, that's going to round down to 0. And when we have the ceiling function of 1/2, that's going to round up to 1. Is 0 greater than 1? No. So we know that A is not true. For every value of x, the floor function of x is less than the ceiling function of x. Well, we see that that's true when x is 1/2. But let's look at an integer. Let's say x is 0. The floor function of 0 equals 0. And we want to know, is that less than the ceiling function of 0, which also equals 0? So this is not true either, and B can't be our true statement. C, if x is an integer, the ceiling function of x, the floor function of x equals the ceiling function of x. Otherwise, the floor function of x is greater than the ceiling function of x. Well, this is true, as we saw with part B. 0, 1, 2, it's always going to equal the integer. However, let's go back to x equals 1/2. Is the ceiling function of 1/2 greater than, I said that wrong again, sorry. Is the floor function of 1/2 greater than the ceiling function of 1/2? Well, we saw with part A that this equals 0 and this equals 1, so this is not true, and therefore C can't be true. However, D says if x is an integer, the floor function of x equals the ceiling function of x. We know that's true. And the floor function of x is less than the ceiling function of x. Well, this is also true, as we saw with the examples. So D must be our correct answer. For items 76 through 78, sketch the graph of each function. 76 is a piecewise function. So, as I explained with the previous problems, I like to find a starting point and an ending point and graph it that way. You absolutely can use slope and one of the points to work that way too, but I'm going to do it this way. So when x is less than -4, that means that I'm going to have this, very bad, sorry, this kind of barrier at x equals -4. So I want to know when f of -4 is with that first function, what does it equal? And since there's no variable, it's going to equal 3, which is going to give us a point of -4, 3. Now I can see with this that it's going to be an open circle because it's less than. So I can plot -4, 3. Now I need to pick another value of x since I don't have an interval that looks like this. I just need to pick a value of x that's less than -4. So I'm going to pick -10. F of -10 is also going to equal 3. So I'm going to have the point -10, 3, which is right there, which means I'm going to have a horizontal line going in this direction. Now we're going to do the 2x plus 1 piece, but we have to look at when f is -4 and when f is 3, because those are the two endpoints of the interval. So 2 times -4 plus 1, well 2 times -4 is -8, -8 plus 1 is -7. So we're going to have a point at -4, -7. So I'm going to plot that point, and I can see that it's going to be a closed circle. Oops. It's going to be right there. Now I need to do f of 3. Well, f of 3 is 2 times 3 plus 1, which is going to be 6 plus 1, which is 7. So I'm going to have a point at 3, 7. So I'm going to plot that. It's also going to be a, sorry again, a lot harder to do this. It's also going to be a closed circle because this is a less than or equal to. Those are my two endpoints. So I'm going to connect them. And you should be using a ruler to make a straight line. I do apologize about that. Actually, what we can do is, if I want to make it more accurate, I know the slope is 2. So from this point right here, I can go up 2 over 1, 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 up 2 over 1. And there, I know it's still not straight, but there's my line. For the last part, I need to do -5, f of x equals -5 if x is 3. So the first point I'm going to pick is f of 3, which is going to equal -5. So 3, -5 is my point. I'm going to plot that. And it's going to be an open circle because this is greater than. Then I just need to pick a point that's greater than 3, so I'll pick f of 10. It's also going to equal -5. So I'm going to have the point 10, -5. I'm going to plot that point, connect them, and I'm going to have a horizontal line. And that is my piecewise function. For 77, g of x equals the square root of x plus 1. There's multiple ways to do this. Honestly, you can plug in points and graph it. You'll have your calculator, but I'm going to talk out how to do it by hand. F of x equals the square root of x. That's the parent function. And we know that that parent function is going to have the points 0, 1, 4, and 9, because these are all perfect squares. So the square root of 0 is 0, square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3. All this function is a transformation, one unit left. So all I'm doing is changing my x values. My y values are staying the same. I'm changing my x values, and I'm subtracting 1. So x minus 1, and so g of x is essentially going to be equal to f of x. So 0, 1, 2, 3. But 0 minus 1 equals -1. 1 minus 1 equals 0. 4 minus 1 equals 3. And 9 minus 1 equals 8. So I'm going to plot those points. -1, 0. 0, 1. 3, 2. And 8, 3. Those are the points that I need in order to graph my function, and that's what it would look like. 78 gives us h of x equals the cubed root of x plus 2. Well, again, my parent function is just going to be the cubed root of x. So the values I want are perfect cubes. I'm going to use -8, -1, 0, 1, and 8. The cubed root of -8 is -2. The cubed root of -1 is -1. Cubed root of 0 is 0. Cubed root of 1 is 1. And the cubed root of 8 is 2. So this is my parent function. However, my graph is being translated one unit up. So my x's are not changing, but my y's are. So my x's are going to stay the same at -8, -1, 0, 1, and 8. But my h of x is going to be equal to my f of x plus 2. Basically, I'm adding 2 to each of my values, to my original parent function y values. So 0 plus 2, this is going to be 1 plus 2, and 2 plus 2. Well, negative 2 plus 2 is 0. Negative 1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3. And 2 plus 2 is 4. So I can plot these points. Negative 8, 0. Negative 1, 1. 0, 2. 1, 3. And 8, 4. So my graph, I can make that better. Sorry. My graph is going to look something, I've made it even worse. Something like that. I apologize. Graphing is a lot harder to do on an iPad. One, 3, 8, 4. That's better. As long as it's got the general shape of the cubed root function, you should be good to go. And the right points, obviously. For items 79 through 81, evaluate f of 1.6. So for 79, we're going to be taking f of 1.6. So this is going to be the floor function of 1.6, meaning we round down. So 1.6 rounded down goes to 1. For number 80, f of 1.6 is the ceiling function of 1.6, meaning it rounds up, and 1.6 rounds up to 2. For the last one, it's a piecewise function of the cubed root of x plus 6.4 if x is less than 2, and the square root of x plus 2.4 if x is greater than 2. Well, we want f of 1.6, and 1.6 is less than 2, so we're going to be using the top function, meaning we're going to have the cubed root of 1.6 plus 6.4. 1.6 plus 6.4 adds to 8, and the cubed root of 8 is 2. So f of 1.6 in 81 is 2. And that is the end of the Unit 5 Algebra Exam Review.